inevitable that the whole Hertz theory of peak oil rests completely on the assumption that oil is a biogenic in origin. Therefore, oil is a finite resource. Simply, everyone believes this because everyone believes that this is a proven fact. I have also read that biogenic theory directly contradicts and offends the second law of thermodynamics. Evidence of the Western biogenic theory of oil formation. First, in 1757, Russian scientist Milaho Lomonosov put forward a hypothesis suggesting that oil came from a biological detritus. This was based upon the theory was first introduced by George Agricola in 1557. George based his work on Greek Aristotle work. In 1757, applying a little more observation and analytical analyzation tools available in his time, Russian scholar Milaho Lomonosov is strongly considered to have farthered the theory that crude oil, after percolating a great duration of time, might originate from a biological material. The notion that oil is a fossil fuel was first proposed by Russian scholar Milaho Lomonosov in 1757. Lomonosov's rudimentary hypothesis, based on a limited base of scientific knowledge, existed at the time, and on his own simple observations was that rock oil originated as tiny bodies of animals buried in sediment, which under the influence of increased temperature and pressure actually during an unimaginable long period of time transform into rock and oil. 2.5 centuries later, the Lomonosov theory remains as it was in 1757. An unimproved and almost entirely speculative hypothesis returned once again to the Wall Street Journal. We find that although the world has been drilling for oil for generations, little is known about the nature and the resource or the underground activities that led to its creation. In spite of a great amount of scientific research, there remains many unresolved questions regarding its origins. Doesn't that seem a little bit odd, what we're talking here? After all, about a resource that plays all crucial roles in a vast area of human endeavors. By one published account, petroleum is a raw ingredient of 70,000 manufactured products, including medicine, synthetic fabric, fertilizers, paint, varnish, acrylic, plastic, cosmetics. By many accounts, the very survival of the human race is entirely dependent on the ability of petroleum, and yet we almost know nothing about this most life substance of Earth resource. And even though, by official accounts, the well is about to run dry, no one seems to be overly concerned with the understanding the nature and the origins of the so-called fossil fuels. We are, rather, with the continuing to embrace the unapproval of the 18th century theory that is, if subjected to any sort of logical analysis, seems ludicrous. As anyone who stayed awake during high school science class knows that oil came from dinosaurs. I remember as a student hearing my teacher go over and over the fact that oil was a fossil fuel and we were running out of it. It seemed a reasonable idea at the time from a perspective of a 16-year-old, but as an adult, you really stop and give it some thought. Doesn't that idea seem, what's the word I'm looking for? Oh yeah, I remember now, preposterous. How could dinosaurs possibly create the plant's vast oil fields? Did millions or even billions of them die at the very same time or at the very same place? Were the dinosaurs drones down on a great scale, occurring in a location all across the planet? And how did they all get buried so quickly? Because if they weren't buried right away, wouldn't they just have decomposed or been consumed by scavengers? And how much oil can you really squeeze from a pile of parched dinosaur skeletons? How many dead dinosaurs does it take to make a barrel of oil? How many barrels of oil have we used so far? If dinosaurs caused the oil, or more correctly, their dead bodies decaying caused the oil, then shouldn't it be a simple formula to figure out how many dinosaurs it took to make oil? Isn't this science in reverse? If oil was a fossil fuel, could you not figure out this one simple fact? Also, wouldn't that make all oil the same age? Wait, if oil were the same age, that would mean that dinosaurs that made all the oil all die at the same time, correct? Maybe there was some type of catalytic event that caused the sudden extinction of dinosaurs and also buried them, like the impact of an asteroid or a comet, but even so, you wouldn't think that all dinosaurs would have been huddled together waiting to become oil fields. And besides, scientists are not backing away of the mass extinction theory. Does this mean that without a mass extinction, we could not have oil as a fossil fuel? Does it also mean that since oil we have today is in oil fields was all made at one time, that all oil came from some sort of sudden extinction? Then if that lived for millions of years before, what did their dead bodies produce? Therefore, it would take a big pile of dead dinosaurs to account of estimate of 660 billion barrels of oil in the Middle East. I don't know what the percent dinosaur carcass to barrel oil conversation rate is, but it does seem like it would take a hell lot of dead dinosaurs, even if we generally allow the single dinosaurs could yield about 5 barrels of oil, an assumption, but let's play along. More than 130 billion dinosaurs would have been sustainably entombed in just one small region of the world. But were there really hundreds and billions of dinosaurs roaming the earth? If so, then one wonders why there's always all these talks about overpopulation and scarce resources when all we are currently dealing with is a few billions of humans populating the same earth. Could the earth have had 130 billion dinosaurs in one place like the Middle East? Now, you would also have to multiply that with the United States, Mexico, Venezuela, Russia, and all other leading oil-producing areas of the world. Quickly, you will see that we would have over 1 trillion dinosaurs on the earth, all dying at one time. We have found some fossil fuels, but have we found them in that type of scale? The answer was sounding no. And why the Middle East? Was that the region some kind of mecca for the dinosaurs? Was it the climate or the lack of water and vegetation that drew them there? Of course, the region would have been much different in prehistoric times. Maybe it was like the Great Valley in the Land Before Time movies. Or maybe the dinosaurs had to cross the Middle East to get to the Great Valley, but they never made it because they just budged down in the desert and utterly became cans of 10W40 motor oil. Another version of the fossil fuel story holds that microscopic animal carcass and other biological matter gathered in the world seafloor, which are organic matter then being covered over with sediment over the course of millions of years. You would think, however, that any biological matter would decompose long before being covered over with sediment. But I guess not, and I guess there's no bottom feeders in those days to clear the ocean floors of organic debris. Fair enough, but I still don't understand how those mass piles of biological detritus constituted of 100 or billions of tons of matter could just suddenly appear so they can just sit there undisturbed for millions of years as were covered over with sediment. But I can't understand how biological detritus would accumulate over time, mix with sediment, and would really create the conditions of a generation of vast reservoirs of crude oil. So I guess I might be missing something here. This theory makes sense, correct? Have we found that some cases of place that has produced oil in the past, West Texas and Middle East, for example, were old seabeds? So maybe this theory is correct. It wasn't the dinosaurs entirely. It was the plants and animals in the ocean that all died. This makes perfect sense until you begin to apply some questions like, did all the plants and animals all die at once? How can you have oil created from the surface of the earth downward and have oil at the top the same age as the bottom? Simply, you can't, because according to their own theory, the oil had been made all at once. For example, let's look at a cook prepared a large kettle of homemade soup. He puts the soup in the kettle, heats the kettle slowly, and then adds different parts of the soup. As the soup is cooking, he continues to add ingredients. He adds ingredients until the exact time the soup is served. Would all the ingredients be cooked? Will all the ingredients be done? The answer is of course not. I realize that this is a soup and it's not oil, but the analogy is very much the same. You must question the fact that biologically speaking, for oil to be biotic, it would have to have a single source or cause and would have to be cooked from the bottom up, not the top down. This means clearly that if oil is a fossil fuel, fossils had been found at the base of the deposits of oil. That means that fossils will be found at levels deeper than oil is currently being pumped at. Today, Russia has an oil well that are overly 30,000 feet deep, yet the deepest fossil fuel has been found at 16,000 feet below the surface of the earth. In conclusion, let's compare the two theories and how oil was created and see which one makes more sense. In the Lomonosov theory of 1757, you either have trillions of dinosaurs dying at the same time, plants and animals in the ocean dying. After they die, they all decay at the same time and create oil. Cross-apply these facts. First, for oil to be a fossil fuel, we would have to be overpopulated with dinosaurs. Second, they all have to die at the same time. Third, Oil on top of the oil field would have to be newer than oil at the bottom of the field. Fourth, fossils would have to be found at the bottom of all areas that have been drilled. The interesting fact is that none of this happened. Bones of dinosaurs have not been found in numbers sufficient to justify point 1. No scientific evidence has been shown to cause point 2. The age of oil in the fields isn't different, and fossils have been found only to 16,000 feet, even though they're producing wells twice as deep. Where are the abiotic petroleum hypothesis first gained significant exposure outside the Soviet Union during the 1977 gasoline crisis, where in Cornell Astrophysics, Thomas Gold published an editorial in Wall Street Journal in which he claimed that most deep hydrocarbons generate abiotically in mantle and migrates to the crust, where they act as an energy source for microbes, producing a deep microbial ecosystem, the deep hot biosphere, that may rival the surface biosphere in the mass and volume. The organic remains of microbes in the deep hot biosphere represents the source of biological molecules in petroleum as a biological overprint onto an abiotic organic mixture. The proposed contains the implicit concession that biological molecules in petroleum cannot be generated by a polymerization of methane. Echoing some of the previous arguments of Russian-Ukrainian school, Gold presents several lines of evidence of abiotic petroleum, including, first, the presence of clearly abiotic hydrocarbons and other organic molecules in meteorites and other solar system bodies. Second, plausible synthetic pathways of mantle hydrocarbon production. Third, the association of hydrocarbon deposits with helium and other trace gases, presumably with mantle sources. Fourth, the existence of extensive deep microbial communities that impart an overprint of biomarkers onto abiotic petroleum. Fifth, the tendency of hydrocarbon reservoirs to occur at many depths in a single locally, implying an underlying deep source. Sixth, the distribution of hydrocarbon deposits related to underlying mantle structure. 7, the distribution of metals and other trace elements in petroleum, which correlate more strongly with chondrite composition than presume crust source. And 8, the occurrence of hydrocarbon and non-sedimentary formations such as crystalline rock. Clearly, at both the abiotic and biotic theories of the creation of oil, we can see which one is scientific and which one is not based on facts. If there are no further questions, I would retire and allow my partner Juan Cruz to stand and present the second point of error. We pray that you vote for the petitioner in this case. Thank you.
May it please the court, your honors, I, Joaquin Cruz, will speak on the second point of error. If we know that oil is not biotic in composition and therefore finite, why are we still believing in the biotic formation of oil? Please cross-apply all my partner's arguments and allow me to begin. The history of petroleum had begun in 1757 when the Russian person of natural gifts, Lomonosov, suggested the hypothesis that oil might originate from biological detritus. During the end of the 19th century, famous Russian chemist Dmitry Mendeleev stated clearly that oil is primordial native material from great depth from the mantle. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not new or recent. This theory was first initiated by Professor Nikolai in 1951, almost half a century ago, and has undergone extensive development, refinement, and application since its introduction. There have been more than 4,000 articles published in the Soviet scientific journals and many books dealing with the modern theory. This writer is presently co-authoring a book upon the subject of development and applications of modern theory of petroleum, for which the bibliography requires more than 30 pages. The modern Russian-Ukrainian theory of deep abiotic origins is not the work of any one single man, nor a few men. The modern theory was developed by hundreds of scientists in the now former USSR, including many of the finest geologists, geochemists, geophysicists, and thermodynamics of that country. There have now been more than 2 generations of geologists, geophysicists, chemists, and other scientists in the USSR who have worked upon and contributed to the development of the modern theory. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not untested or speculative. On the contrary, the modern theory was severely challenged by many traditional-minded geologists at the time of its introduction and during the first decade then after. The modern theory was thoroughly examined, extensively reviewed, powerfully debated, and rigorously tested. Every year following 1951, there were important scientific conferences organized in the USSR to debate and evaluate the modern theory of development and its predictions. The All-Union Conferences in Petroleum and Petroleum Geology in the years 1952 to 1965 dealt particularly with this subject. During the period when the modern theory was being subjected to extensive critical review or testing of the traditional hypothesis that petroleum might somehow have evolved spontaneously from biological detritus. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not a vague qualitative hypothesis, but stands as a rigorous analytical theory with the mainstream of the modern physical sciences. In this respect, the modern theory differs fundamentally not only from the previous hypothesis of a biological origin of petroleum, but also from all traditional geological hypotheses. Since the 19th century, knowledgeable physicists, chemists, thermodynamics, and chemical engineers have regarded with grave reservations the suggestion that highly reduced hydrocarbon molecules of a high free enthalpy might somehow evolve spontaneously from highly oxidized biogenic molecules of low free enthalpy. Beginning in 1964, Soviet scientists carried out extensive theoretical statistical thermodynamic analysis which established explicitly that the hypothesis of evolution of hydrocarbon molecules, except methane, from biogenic ones in the temperature and pressure regime of the Earth's near surface crust was glaringly in violation of the second law of thermodynamics. They also determined that the evolution of reduced hydrocarbon molecules requires pressures of magnitudes encountered at depths equal to such of the mantle of the Earth. During the second phase of its development, the modern theory of petroleum was entirely recast from a qualitative argument, based upon a synthesis of many qualitative facts into a quantitative argument, based upon the analytical arguments of quantum, statistical mechanics, and thermodynamic stability theory. With the transformation of the modern theory from a synthetic geology theory, arguing by persuasion, and into an analytical physical theory, arguing by compulsion, petroleum geology entered the mainstream of modern science. The modern Russian-Ukrainian theory of deep abiotic petroleum origin is not controversial, nor presently a matter of academic debate. The period of debate about this extensive body of knowledge has been over for approximately 2 decades. The modern theory is presently applied extensively throughout the former USSR as the guiding perspective for petroleum exploration and development projects. There are presently more than 80 oil and gas fields in the Caspian district alone, which were explored and developed by applying the perspective of the modern theory and which produced from the crystalline basement rock. Similarly, such exploration in the Western Siberian Cratonic Rift sedimentary basin has developed 90 petroleum fields, of which 80 produce either partly or entirely from the crystalline basement. The exploration and discoveries of the 11 major and 1 giant field of the northern flank of the Dnieper-Donetsk basin have already been noted. There are presently deep drilling exploration projects underway in Azerbaijan, Kyrgyzstan, and Asian Siberia, directed to testing potential oil and gas reservoirs in the crystalline basement. It appears that, unbeknownst to the Westerners, there have actually been for quite some time now 2 competing theories concerning the origins of petroleum. One theory claims that oil is an organic fossil fuel deposited in finite quantities near the planet's surface. The other theory claims that oil is continuously regenerated by natural processes in the Earth's magma. One theory is backed by a massive body of research representing 50 years of intensive scientific inquiry. The other theory is an unproven relic of the 18th century. One theory anticipates deep oil reservoirs, refillable oil fields, migratory oil systems, deep sources of generation, and spontaneous venting of gas and oil. The other theory has a difficult time explaining any such documented phenomenon. So which theory have we in the West, in our infinite wisdom, choose to embrace? Why the fundamentally absurd fossil fuel theory occurs? Of course, the same theory that the peak oil doomsday warnings are based on. I'm sorry to report here, by the way, that in doing my homework, I never did come across any of that hard science documenting peak oil that Mr. Straw referred to. All the peak oil literature that I found on Rupert's site and elsewhere took for granted that petroleum is a non-renewable fossil fuel. The theory is never questioned, nor in any effort made to validate it. It is simply taken to an established scientific fact, which is quite obviously not. First, look at the abiotic hydrocarbons in space. Carbon is the fourth most abundant element in the cosmos, and remote observations indicate that the universe is a replete with organic compounds produced without the influence of biology. Studies of the absorption spectra of dense molecular clouds, several more than 150 molecules, the greatest amounts of hydrocarbons in our solar system are associated with the gas giant planets and their satellites, where significant amounts are present in atmospheres and on icy surfaces. The prevalence of non-biological hydrocarbons in the early stages of our solar system is evidenced by the chemistry of carbonaceous meteorites, which represent fragments of ancient asteroids unchanged since shortly after the birth of the solar system. Carbonaceous meteorites contain percentage levels of organic matter that were generated in the absence of biology. The widespread presence of organic matter in cosmos suggests that no exotic mechanism therefore need to be invoked to propose abiogenic hydrocarbons on Earth. In fact, the biogenic origin of some hydrocarbons on Earth is thus far a unique observation in an abiotic hydrocarbon-rich universe. In contrast to our cosmic environment, organic matter on Earth is associated primarily with biological processes. The distinction between biological and non-biological organic matter has held a long-term fascination for scientists and philosophers. For instance, all ancient mythologies invoke divine intervention and the use of some abstract vital force for the production of organic compounds that constitute life. Following the 7th and 6th centuries BC, such vitalist theories were often challenged by more materialistic concepts that assumed only differences in levels of organization between living and non-living entities. A key moment for materialism came in 1828 when Friedrich Wohl produced the organic chemical urea from inorganic ammonium cyanide using a procedure now called the Wohl synthesis. The generation of an organic compound from inorganic material reflects the ability of non-biological processes to produce organic materials. And it is an unavoidable conclusion that the origin of life on Earth was by the definition a process of abiogenic organic synthesis. In the general organic compounds generated by abiotic reactions such as those produced in meteoritic organic matter are characterized by the complete structural diversity. Biological or organic compounds produced by synthetic reactions directed by enzymes are notably specific in the structure. Organic compounds in petroleum, by contrast, contain numerous structures in abundances that could not be produced by the random polymerization from methane. Second, experimental hydrocarbon synthesis. Hydrocarbon synthesis is achievable under laboratory conditions and in shallow geological environments, and several key reactions are notable. First, the Fischer-Tropsch synthesis involves the conversion of carbon monoxide or carbon dioxide to hydrocarbons. The products of the Fischer-Tropsch synthesis are low molecular weight hydrocarbons and often form a Schultz-Flory distribution, where the log of the hydrocarbon concentration decreases linearly with increasing carbon numbers. The Fischer-Tropsch process has been proposed as a generator of hydrocarbons in hydrothermal vent settings. Second, simple thermal metamorphism of carbonates such as calcite, dolomite, and siderite at 400 Celsius in the presence of hydrocarbons can produce low molecular weight hydrocarbons, as in the following unbalanced reaction. Third, thermal metamorphism of carbonites and graphite below 300 or 400 Celsius may generate methane, as displayed in the following unbalanced reaction. Fourth, methane is common at mid-ocean ridges, and serpentinization reactions are implicated. Hydrogen forms during the hydration of olivine and can combine with carbon dioxide to form methane. In addition to those reactions that proceed under conditions relevant to Earth's near surface, the influence of pressure may be an important factor for synthesis. This environment control is especially pertinent to the theories of deep gas, and a number of experimental studies at elevated temperatures and pressures relevant to the crust and mantle conditions point to the possibility of deep abiotic hydrocarbon synthesis. First, the generation of petroleum hydrocarbons was demonstrated using solid iron oxide, marble, and water at temperatures of 1,500 Celsius and pressures above 3 GPa, corresponding to a depth of more than 100 kilometers. Second, a heated diamond anvil cell has been employed to explore the calcium iron oxide water system as mantle pressures and temperatures. Based on Raman's spectroscopic and X-ray diffraction evidence, methane and possibly other light hydrocarbon species were successfully synthesized through an unbalanced reaction. The Scott experiments represent the first attempts to test the Russian-Ukrainian school hypothesis under conditions comparable to those found in the mantle. Subsequent experimentation has successfully repeated the observations. Third, pressures above 2 GPa and temperatures from 1,200 to 1,500 kelvins appear to introduce polymerization of methane to hydrocarbons, molecular hydrogen, and graphite. The reaction is reversible under these conditions. Although elegant and efficient reactions exist that can produce substantial amounts of hydrocarbons from simple precursors in the absence of biology, care must be taken when extrapolating data to natural settings. Convincing evidence must be found that the production mechanism is contributing. Lessons can be learned from meteoritic organic matter studies where the attractive Fischer-Tropsch mechanism was supported, even though ample evidence was available that this reaction was not contributing quantitatively significant amounts of material to the organic inventory. Third, hydrocarbons and minerals. Evidence has been presented from organic proto-molecule assembly in igneous rocks. According to Freund's hypothesis, igneous melts inevitably incorporate carbon and other impurities at high temperatures. As minerals crystallize, they also incorporate small amounts of carbon, which concentrates along linear crystal defects and from alkenes. However, these results have been challenged by other workers. Fourth, abiotic hydrocarbons from hydrothermal vents. A number of authors have presented experimental, theoretical, and field evidence for the possible release of abiotic hydrocarbon species from hydrothermal vents. Hydrocarbons have been collected from numerous field sites. Observations of gas chemistry, abundance, and fluxes in various vent settings have provided an opportunity to assess quantitatively the relevance of proposed abiotic species to commercial oil and gas resources. Mean values of molar mantle-derived fluids imply that less than 200 ppm of abiotic gas are present in economically relevant reservoirs. These field observations of hydrocarbons from hydrothermal systems have been complemented by experimental studies that attempt to replicate natural conditions. A number of these experiments have demonstrated abiotic formation of methane and other organic compounds, particularly in the studies that mimic serpentinization. The experiments underscore the importance of a transition element in the hydrothermal synthesis of organic molecules by the Fischer-Tropsch type reaction. These results suggest an intriguing connection between mineral-mediated organic synthesis and biological catalysts, many of which incorporate transition metal atoms and their active sites. Biochemical reactions promoted by enzymes that incorporate transition metals may thus represent reaction pathways that have survived and evolved from the biotic geochemical world. Cross-apply, the main argument put forward by the Western biotic oil theorists, is that biomarkers are always found to exist as organic detritus within all oil deposits, which is certainly true. But unfortunately, oil exists inside the earth and is surrounded by different types of geological soils, which all contain organic detritus. And oil is a wonderful solvent in which to dissolve and hold its detritus. Also, and by the reverse argument, alkenes, kerogens, and many other petroleum-related chemicals have been found on meteorites, which can support no organic life. Cross-apply the fact that no fossils have been found below 16,000 feet, yet oil is being currently drilled for up to 40,000 feet, yet you are left with a controversy. Why are we not told the truth? 7 reasons we are not told the truth about the source of oil. First, in the paper, The Abiotic Oil Controversy by Richard Heinberg, which sides with biogenic oil, with relatively little actual quoted research evidence has been admitted. There is no way to conclusively prove that no petroleum is of abiotic origin. Perhaps one day there will be a general agreement that at least some oil is indeed abiotic. Maybe there are indeed deep methane belts 20 miles below the Earth's surface. But the important question to keep in mind is, what are the practical consequences of this discussion now for the problem of global oil depletion? Cross-apply the facts can't prove it isn't. Cross-apply some maybe. Although by doing this, the biotic oil theorists are really tearing down their own theory. Cross-apply that the really problem here is for the abiotic oil theorists is not how oil is created, but that it's running out. This is a logical fallacy, creation of a false dilemma. How can you run out of a product that is unlimited? Second, American geologist King M. Hubbard predicted in 1956 that peak oil for the U.S. will peak in 1970. However, in the December of 2014, the United States once again leads the world in the production of oil, actually producing more oil than it did in the 1970s. Cross-apply the fact that oil prices from August 2014 to December 2014 fell by over 50%. If Hubert's theory of peak oil were correct, neither of these two facts would have taken place. Clearly, peak oil and the price of oil were trying to manipulate the demands of oil by creating a false sense of running out of oil. With a limited supply, demand, and prices go up, cross-apply the fact that supply has gone up, prices have gone down, causing the best proof that peak oil as theory is completely dead. Third, cross-apply the fact that the laws of thermodynamics prohibit spontaneous evolution of liquid hydrocarbons in the regime of temperature and pressure characteristics of the crust of the earth. One should not expect there to exist legitimate scientific evidence that might suggest that such could occur. Cross-apply, there exists no such evidence. Nonetheless, and surprisingly, there continue to be often promulgated diverse claims purporting to constitute evidence that natural petroleum somehow evolves miraculously from biological matter. Fourth, oil is often called a fossil fuel. The idea being that it comes from formerly living organisms. This may be plausible back when oil wells were drilled into the fossil layers of Earth's crust, but today's great quantities of oil are found in deeper wells that are found below the level of any fossils. How could then oil have come from fossils or decomposed form of living matter? If it exists in rock formations far below layers of fossils, the evidence of formerly living organisms, it must not come from living matter at all. 2 days after I read this statement, I encountered the following statement in the newspaper I deeply respect. Most geologists will tell you that oil is created by the magma of the earth. The oil wells in Pennsylvania that were pumped out by the dry at the turn of the century and capped are now filled with oil again. The response is for Daniel E. Reynolds, 29 July 1996, on the subject of oil, a renewable and abiotic fuel. Cross-apply the only reason why we are still being taught that oil is a fossil fuel is to control the price of oil and to aid in the in the story that we are running out of oil. Fifth, Academy of Scientists Moscow. For almost a century, various predictions have been made that the human race is imminently going to run out of available petroleum. The passing of time has proven in all those predictions to have been utterly wrong. Cross-apply how all predictions have depended fundamentally upon an archaic hypothesis from the 18th century that petroleum somehow evolved from biological detritus. Consequently, the DDB's northern flank earlier was qualified as not prospective for petroleum production due to the absence of any source rock of petroleum and to the presence of an active, highly dynamic Argentinian aquifer. However, after a while, the prospectivity of its area was reinterpreted, re-examined in compliance with the theory of the abyssal abiogenic origin of petroleum. In the end, you would have to agree that Russian abiotic theory of oil formation, backed up by all its evidence, is far more likely to be true explanation, and there appears to be little or no conclusive evidence to prove the Western biotic theory of the oil. But that in itself leaves much unanswered questions, does it not? For what reasons then, in light of these facts and conclusions, is the peak oil theory being so heavily touted, a theory that is wholly dependent on the Western biotic theory of oil formation, which as I see it, is completely unproven theory? Are Western geologists and scientists really that stupid or unfair, or is there an underlying hidden agenda and the media's steerage here? The only one to gain from taunting this theory are the oil companies themselves. They pushed oil to record heights and held the developed world hostage to their whims. Then in the summer of 2014, a break in the stranglehold they once held, OPEC, on the exporting of oil. This was because of a national greed and the fact that US is now producing vast more sums of oil. Prices have dropped by more than 50% from June to December 2014. I leave you with this question and a prayer. Could oil actually lose 50% of its value if we were running out of it? And why is it? For those reasons, we ask you find in favor.
Thank you. Can you hear us? Can you hear? Okay, you can hear. All right.
Go ahead, Iran.
Hi, can you hear us?
We can hear you fine now. Go.
Great. Okay, so we're gonna give our speech now. Hi. Okay. Oil is the #1 source of energy in the world and has been so since the middle of the 20th century. But ever-increasing demand has caused the price to spike in recent years, and only the world economic crisis was able to temper demand and bring the price down to more reasonable levels. However, the demand and price have been increasing again as the world economy recovers. At the same time, the peak oil theory of Hubbard 1.2 predicts that world oil supply has already peaked or is likely to peak soon. That puts even more upward pressure on the price of oil. It is obvious that oil is a finite resource and that eventually world oil production will peak, and at some point in the distant future, we will run out of it. Discoveries made by geological studies must be integrated in any sound theory of petroleum formation. Petroleum geology and exploration is an empirical and pragmatic field which has evolved by trial and error. Geologists and oil companies have learned where to drill and where not to drill, and thus developed a theatrical model that works and corresponds to the reality. The model is consistent with the biogenetic theory of oil creation. In the real world, the truth of the borehole speaks louder than any theory, since it provides actual production flows. Needless to say, the drilling dome in the line with the biogenic theory of oil formation has resulted in a vast amount of oil that has been of benefit to mankind since the beginning of the oil era. This has been verified by geochemical and geological studies that are accepted by a broad majority of researchers and experts within the scientific establishment and the petroleum industry. Modern petroleum geology does not deny the existence of commercial amounts of abiotic oil. The abiotic theorists would surely win more credibility if big oil fields could be found supporting their theory. Glaspie, 2006, highlights how researchers have been unable to cite any commercial occurrence of a biotic petroleum, despite a long list of promising places such as Saigon Ring offshore Vietnam and in the Gulf of Mexico. In fact, the petroleum resources of those regions can be explained entirely within the biogenetic framework. Scientific support can be found for both biogenic and abiotic theory of petroleum formation. However, theatrical studies, laboratory verification, and discoveries of trace amounts of abiotic oil do not imply the existence of commercially significant deposits. The abiotic theory of oil creation can be summarized as a question. If abiotic petroleum exists in large commercial amounts, where is it hiding? Thank you. That was our speech. Okay. Thank you.
Yeah.
Can you hear me?
Yeah, we can hear you.
Is that the first speech? Is there gonna be a second speech, or that's?
No, actually, the information we got was that we only had one speech. But thanks for your speeches.
Oh, okay. I guess we'll start with questions.
Okay.
Just leave. Okay, so I'll begin.
Okay.
If we're running out of oil, then why have oil prices decreased, and why has oil companies not led into renewable energy?
Okay.
Yep.
Well, the Hubbard theory predicts, as we said, that oil would have been peaked by now. It said that in the year 2000 it would have ended, but there are some other factors in the thing that Hubbard did not understand, like he didn't think of them. Therefore, we believe that the oil will be ending soon, and the Hubbard theory is actually true. So that answers your question.
And the thing that he didn't think about was that oil wasn't created about dinosaur skeletons.
Can you hear me?
Yes.
Yeah, we can hear you fine.
So, no, the influence that we were talking about is the influence of prices. That the price affects the usage, the amount of usage of oil throughout these years. So that's what Harvard didn't predict in his statement.
If you're running out of something, then prices go up.
Yes, that was actually one of the things Harvard said. It said that we will keep selling it and selling it and selling it, and it will go higher and higher, higher until we reach an end, and then we will just drop down. That's his theory that we believe in.
When we drop down, we're drilling more oil than it would cost less, correct?
1 second.
And we're also drilling more oil than we're doing today. I mean, we're drilling more oil today than we did in the peak prehistoric time. And it costs less than before.
Can you ask your question? Because we understand what you're saying and it's correct. Just what is your question here?
Yeah. You want to?
It's not a question, they're asking for a question.
Yeah.
So you stated that Hubert did not think of these factors and therefore his theory was wrong. So you are stating that his theory is wrong in and itself, correct?
No, we're saying that his theory is completely correct. Just the thing that went wrong was that he didn't know about some factors that became after Hubbard. His theory is correct, just the time is different.
If his theory was correct, however, you state that there is flaws in his theory, so couldn't there be a flaw in the whole theory itself?
Well, we're not saying there's a flaw in his theory. He gave a time for his theory. He said it would end in 2000. Well, we think that that's wrong. That is the only thing that's wrong with it, and that's because the factors became after. And the factors that were added after Hubbard were human factors, were the usage of oil, not the amount that oil, the amount of oil we have.
Is oil being used today more than before? Can you hear me? Hasn't the demand for oil increased today?
Yes, that's true.
Hasn't the prices also gone down?
Yes, that's a historical fact. Yes, that's true.
Those two alone disprove your theory, correct?
Excuse me? No, that's not true.
No, we said that the drilling of oil would increase throughout the years and then drop low. But what you're stating is the price of this oil, which is influenced by the social reasons. Like, for example, countries don't want to sell their oil because they want to preserve it for later so they can sell it for a higher price. So that really does not matter to the science part of it. It's more political reasons.
Yes, and that exactly proves our fact that we believe that oil is finite and it's going to end someday, which is why we're trying to preserve it and not like different countries are doing it. They're keeping their oil and preserving it so they can sell it later for a higher rate.
But if we're running out of oil, then why does it cost less? Shouldn't it be causing more? Shouldn't the cost increase?
As I said in my speech that increasing demand has caused the price to spike in recent years, but the world economy crisis was able to temper it down because like humans come first, right? Because we need it. So what are we going to do? If it's too high, then they can't buy it and we actually need it, you know? So there's no other option other to lower the prices.
If it's a finite source, doesn't the price go up?
Like I said, sometimes the world thinks about right now and we need it right now. So how are they going to sell it at a higher rate when the need is still there, you know? The people still need to use it, so they can't lower it, they can't high it because people need to use it right now.
Are you not aware of the supply and demand theory? If there's a high demand for something, the supply will be reduced. However, it doesn't necessarily mean there is a limited supply. It just means that prices will rise.
Yeah. Yeah. Do you have any questions for us, Kherad?
Yes, we have some questions for you. 1 minute, please.
Okay.
Okay, so we have a few questions. Okay, So in the process of the making of your abiotic theory, you say that this oil is in the deep crust of the earth. So it's in a really heated part of the earth. But in fact, we have progressive destruction of oil when heated over 100 degrees was shown. So how can you explain the amount of oil that you're saying that is in the deep part of the earth?
Alam niyo yung jawab niya, bakit mo siya? Ako ba check mo?
All right. The oil is when things are made, it's not necessarily destroyed the same way. Oil is created through the heat and pushed up to the mantle. However, some of the oil is still lost. Not all of it goes up to the closer to the surface of the earth. So your question about it would be impossible for the oil to be created is not necessarily true, because some oil is lost. However, most of it is still created.
And we are currently pumping oil that are more deeper than 16,000 feet deep.
Okay, so you say 60,000 feet.
More than 16,000 feet.
Over 60,000 feet. But in fact, the technology for you to be able to dig that hole is kind of impossible. Especially the prices will be so high that it's really impossible. It's really impossible to do that. If you have managed to make and dig a hole over 60,000 feet, that's that deserves like a Nobel Prize. It's a new technology that we do not have.
It's 16,000 feet, and Russia is currently pumping and has currently pumped more than 16,000 feet. So we can explain that they can go deeper than 16,000 feet.
Okay, well.
Okay. Another thing we want to tell you is that we do not have evidence that what the Soviet Union and what Russian scientists say is in fact true. What we do know for certain is that we cannot see massive pipeline systems around the places that they say they have found these holes, these abiotic oils. But we need pipelines, enormous pipelines, in fact, to be able to move any large amount of oil away from the hole in the ground. But we cannot see that.
Russia has been an import of oil and gone to an export of oil in plenty of years.
That does not state that they have done this technology. A lot of countries are producing oil and exporting it. That doesn't mean that they have such a big technology working for them. These pipes are something enormous and unbelievable, and that doesn't mean that they're using this technology to produce the oil. They're using the same technology that other countries are, so it will be ending soon.
Actually, it does. The Russian example we gave actually does explain that they do use this technology, because they have, before World War II, they were one of the largest importers of oil. However, after 50 years, they've become the greatest exporter in the world of oil, meaning that this abiotic theory that Russian scientists all qualify is true, because it is evident in their economy that oil is replaceable and not biogenic itself, but abiogenic.
Okay, another thing I want to say is that you say Russia is now one of the top countries in exporting oil, yes? But in fact, we know that the most former Soviet and the current Russian oil production has come from giant oil fields such as Samochlar and Romashkino, and they are areas, they are holes that can be explained, are really well understood geological control over the oil. So these parts, the part that the oil comes from is actually biogenic.
Just because it's located somewhere where there is biogenic things does not necessarily mean it produces the resource being produced.
And the deepest fossil fuel has been found at 16,000 feet, and we're pumping oil from lower than that. 40,000 feet.
One second. We have a question in answering yours. We would like to know if there is such technology in Russia, why isn't any big company putting their money on it? Because this could be huge. This could solve half the world's problems. So why isn't a big company putting their money on such amazing technology and a new idea?
Big companies are investing their money in this. However, they're not necessarily telling the public because it's not in their best interest. By investing into these things, they are making a lot of money. However, the big companies do not necessarily want to help out people. They simply care about expanding their pockets.
They care about the amount of money that they're going to get.
You talked about the money problems, which is in fact what we are focusing on with the Russian government. In fact, if the Russians say that we have this technology, that oil is not going to run out, they can sell their oil. So it's amazing for their own country. So we say that maybe we have no proof what the Russians are saying is in fact true. Only Russian people are supporting their own idea. This may be even a propaganda.
Russia told the public that they had like an increasingly amount of oil, then the price would definitely go down. It would decrease because public would know that they have essential amount of oil.
One of the things that you said is that if oil is ending, then why don't they sell it at a higher rate? Well, then, if you don't think that it's ending, well, then why doesn't Russia fix their money problems by telling the people that yes, in fact, it will end soon, so they can sell it at a really, really high price, and then their money problems be solved like that. So how do you explain that?
Russia's economy is actually improved because of the oil they have, which balances out their economy because it's a big reserve of cash.
Can we ask you a couple questions on something else?
Yeah, sure.
Okay, there's a lot of talk here, excuse me, or Bill, there's a lot of talk here about sanctions and lifting of sanctions. How important is lifting of sanctions there for the people in Iran?
Okay, 1 minute. Can you come again with your question? Because we're not sure we understand.
Okay, yeah, I was saying, since we've had talks and ongoing talks between the United States and Iran on several issues, and some of the issues are about to raise the sanctions, and a lot of people, especially some of my students here, don't really know how hard-hitting the sanctions are against Iranian people. How important are raising the sanctions to the people of Iran?
Okay, since we're talking student to student, the effect that the removing the sanctions would have on people, actual people, would be really well, because the countries would be able to communicate easier. It would be a different new era. We could Americans can come to Iran, Iranians can go to America. It could become a new era. Also, yeah, that's it.
I got one more question. I don't know, it may be too topical, but the United States and the Republic of Iran are having differences of opinion over what's taking place in Yemen with boats and different things. How important is it for young people to understand politics and try not to do some of the mistakes of their adults?
Okay. Our subject for today was
Yeah,
energy.
okay, I understand. No further comment. I understand completely. Okay, we really appreciated talking today. I think it's really important to continue talking because, you know, I think that's the only way we can overcome a lot of different issues.
This
And
topic was actually one of our best topics because it was really interesting for us to research on it, and it was a very hot topic. Thank you.
yeah, and what's really kind of fascinating is that both the United States and Iran produce an awful lot of oil. And, you know, and it may, you know, if it's really true that people have been telling us stuff, that it may or may not be true. I don't know. We're just talking about theoretical things. But you did bring up a very interesting point, is that sometimes in the capitalist system, companies do not tell you everything so they can make money instead of worrying about the needs of people. So, you know, it may be more important to put the needs of people out ahead of the needs of making money for a company. And in that case, you could ever get to whatever the truth may be.
This is truth versus economy.
Yeah, you know, it's really good. When do you girls get out of school?
We got out at 3.
No, I mean for the school year.
Oh, 4 years.
Never.
In 4 years, we're first year of high school.
No, I meant, when does your school year end this year?
In June.
In June, okay. You think we could do another one in May over some kind of food? We're having a real big food conference, but it happens to be on the Friday, and that was not my fault. We're just doing it. But we're getting a group of people from Peru, and they're actually putting on chefs. And what they want to try to do now is you're going to make some dishes and then send them to us. And then we're going to have a professional chef actually cook it for you in Peru, and they're going to make some Iranian food. So it's going to be really kind of neat. And then they're going to put a dish on their in their restaurant. It'll be like Iranian whatever, and so it's going to be kind of a neat thing. So we're going to send you back some stuff on some different dates. It'll probably be on the Tuesday or Wednesday morning. So it'll be Tuesday, Wednesday afternoon your time. So it'll be before, you know, the holy days. Okay. Thank you so much, and thank you again. Goodbye. Bye from the U.S.